Let's start with the another question which is related to the logarithm based. Okay. So now try to understand this one question. So what he has given, if A, B and C are positive real numbers such that the one condition is given. Okay. This condition is what? A is greater than 10, greater than or equals to B, or greater than or equals to C is given. Okay. Fine. We'll solve this first. Whatever the given condition is there, then we can use this condition right afterwards, and the logarithm expression is given everything. So then the greatest possible integer value of A is asking. Okay, so we have to find the greatest possible integer value of A. ಹೌದಾ? So A ಗೆ greatest possible integer value ಏನಿದೆ that ಅದನ್ನು ನಾವು find out ಮಾಡಬೇಕು. Okay, so first we will analyze this one question. Now when we observe here, in case of this, see, in case of logarithms, one rule we know that all the bases should be same. In this given question, if I observe the bases, here we have the 8 and it is 2, and we have it is 27 and 3. So bases are not same. So let's take it as a minimum base, whatever it has given it is 2. Can I take the 8 as a 2 cube? Yes, it is possible. And similarly, 27 is as a base 3, we can take it as a 3 cube. Okay. So one step we will, just one step we are skipping now. Directly we will write down this. So log A plus B to the base 8 is given, and upon log C base 2 is given. Okay. So now see, this we can write it as log A plus B, and 8 we are writing it as a 2 cube. So 8 na 2 cube anta nan tagobodu. Okay. Divided by, that is upon log C base 2. Okay. Now first understand this one condition. Whatever he has given, this try to understand this one first, then we will simplify that directly. Okay. Otherwise the steps will increase. Okay. So try to understand this one. We will simplify. Suppose if you are thorough with the rules, then you can do it directly here. Okay. Those who doesn't understand, so those who don't know, so just I am just telling you the step by step methods. Just try to understand here. Okay. See, in the previous classes we have learned the logs rule. Okay. One of the question were having the one log rule, right? So when I observe this particular numerator part, it is having, the base is having the power. Whenever we have the power to the base, so we have learned that. So log A to the base B power m. Okay. So to the base the power is m, in the sense it will get reciprocal and it will multiply. That is what we have done, right? So m we can take it as a reciprocal like 1 upon m. So it is 1 upon m into log A base B. Okay. 1 upon m into log A base B. Okay, that is the one rule we can use here. So based on that, see here, log A plus B is as it is. Then the base is 2 here. Base is having the power 3, that will get reciprocal, which means it is a 1 upon 3. Upon, this is not having any power, right? So we will write down as it is. Next, one more rule what we can apply here, see here. This log A plus B and base 2 and log C base 2 is there. Once we observe here, both the numerator as well as the denominator is having the base as a common, like a 2 is there, right? So one condition in case of logarithm, we know that log A plus B base 2, we can write it as log A plus B upon log 2. I hope it is clear. So using this one concept, I'll keep 1 by 3 as it is. So log A plus B base 2, which is can be written as log 2 upon, again this one also we will simplify as a log C upon log 2. And these two will get cancelled. What we left is log, because it will get reciprocal any, so log 2 and log 2 will get cancelled, and what we left is log A plus B and base is C here. I hope it is clear. See, entirely this one, if you are thorough with the rules, in the sense, directly we can avoid these steps and directly we can write down this one step. Otherwise it will be like a lengthy questions only. Lengthy question only, it looks like a very lengthy. So what we'll do is, suppose if you want, you just pause the video and copy down this entire thing. So next, whatever the term we were having, we'll do it directly here. Okay. So this is what we can simplify this. So entirely I can write down this as 1 upon 3. See, 1 upon 3 is common here. So 1 upon 3 what we are having, we'll take as it is. 1 upon 3 into log a plus b, a plus b, and the base we are having c. Okay, so that is the simplified form of this condition. Okay, so based on the same rule, we can simplify the next step also. Plus, in case of this, see, in the numerator we have a 27. 27 as a base 3, we can take it as a 3 cube. 3 cube in the sense, if you are getting confused here, so to simplify here it is a plus b, a minus b, sorry, a minus b, 27 can be taken as 3 cube. Again, this base 3 is having the power 3, so 3 taken as a reciprocal 1 upon 3, right? So again, here also, in this case also, we are getting 1 upon 3 common. So 1 upon 3 into log, and now observe the same thing. Here, for the numerator part also, we are having the base as 3, and in the denominator also, we have the base as 3. So both will get cancelled based on the previous rule what we have learned. So by this, directly we can write that log a minus b, and it is having the base as 3. Okay, I hope it is clear. If it is not clear, please pause the video and go back once again and try to solve this and write down these conditions. Okay, so this is the simplified form of this entire equation. So this is equal to what he has given, 2 upon 3. Now once I analyze here, this is 1 by 3 into 1 by 3 into 2 upon 3 is there. We can just cancel out this 3 and 3 so that the calculation part will be very easy. So what we left is log a plus b and base c plus sign log a minus b base c is equal to 2. Okay, so that is what we have left now. Okay, now first rule of the logarithm, whenever we have the addition sign and the bases are same in the sense, the result can multiply, right? So by this rule, I can say that the log is having the common base c, and the result we can multiply, which is a plus b into a minus b. One step again we will avoid here. Since a plus b into a minus b is there, a standard algebraic formula is there, right? So a plus b into a minus b can be written as what? A square minus b square. So now this is what we have left. We have just simplified this and we got this final result. Okay, so since we are having the logarithms, right, log a square minus b square base c is equal to 2, what we have left now. But is this the right answer, that what we require? No, right? Because we want to find the value of a. Since we want to find the value of a, again we have to simplify this. So the logs we will simplify as the integers. Okay, so next step we will convert this entire log to the integers. So integers procedure everybody knows, right? So converting a log to the integers. To the base c, the power is 2, then the result is what? A square minus b square. Still, what we required is the value of a. Since we require the value of a, better to strip the b square this side. So this will be c square plus b square, which is equal to a square. Now is this the final answer? No, right? Because he has given one condition, that condition now we have to use it. What is the inequality condition he has given? A value should be greater than 10, which is greater than or equals to b and greater than or equals to c. Now what does it mean by this? Since we have the equality condition ಇದೆ. So equality condition ಇದೆ ಅಂದ್ರೆ ನಾವು b ಮತ್ತು c value ನ 10 ಅಂತ ತಗೋಬಹುದು, right? So see, why you are taking that, ma'am, in the sense, ಅದಕ್ಕೊಂದು reason ಇದೆ. ಏನಂತ? Condition ಅಲ್ಲಿ question ಏನಿದೆ? Greatest possible integer value of a ಅಂತ ಇದೆ. So maximum ನಾನು a value ನಾನು ಏನು ತಗೋಬಹುದು? So maximum value of a ನಾನು find out ಮಾಡಬೇಕಂದ್ರೆ b ಮತ್ತು c value ನ ನಾನು maximum ತಗೊಳ್ಳೇಬೇಕು, right? So what we can take as a maximum of b and c, that is 10 only, because clearly has mentioned that it is equal to, equality sign is there. So 10 is equal to b, again b is equal to c, in the sense the b and c value we can take at max as a 10. Okay, so based on that rule, and the question is asking that we have to find the greatest possible integer value of a, I can take c and b as 10, right? So we will simplify this bit orally, because once we know that b and c value we can take as a 10, so c square, which is 10 square and 10 square. So we know that 10 square is 100, 100 plus 100 will give us a 200. So what we left us, a square is equal to 100. when a square is equals to 100 in the sense it is a is equal to square root of 100. So, sorry, 100 plus 100 in the sense it is 200, right? So 100 plus 100 is 200. So the square root of 200 we got. But as we know, square root of 200 is not a perfect square root. So I have to take the approximate value because we need to find the greatest possible integer value. Because when I observe the root over 200, it is very much nearer to the 14 square. Now what is the 14 square? Which is 196, right? So this root value is approximately 14 point something. But this is the not final answer because we have to find the integer value which should be our greatest. So the integer value he is asking. So finally I can take the value of a as 14. So this is the right answer for this question. I hope it is clear. Just pause the video and understand the conditions what we have taken, and it was the easiest question from the logarithm. Yes? Yes.